In this video, we are overclocking the Intel Core i5-12600KF processor all the way up to 5.5 GHz in 5 minutes or less. We'll be using the Asus ROG Strix Z690A Gaming Wi-Fi D4 motherboard with DDR4 and an EK all-in-one water cooling. I'll speedrun you through the BIOS settings and provide some tips and notes along the way. Please note that this is for entertainment purposes only, so don't just outright copy the settings from this video and apply to your system. If you want to know how to overclock this system, feel free to check out the longer Scatterbencher video that's already up on this channel. Alright, we have a lot to go through, so let's get started. When you've entered the BIOS, go to the AI Tweaker menu. Set AI Overclock Tuner to XMP2. This will enable the XMP profile and let our memory run at its high frequency specification. Set Asus Multicore Enhancement to Enabled, remove all limits. This will unleash the Turbo Boost 2.0 power limits and allow for an unlimited time at maximum performance. Set Performance Core Ratio to bi-core usage. Now we will configure our dynamic P-core overclock with as goal to maximize the performance in a wide variety of workloads ranging from light single-threaded workloads to heavy all-core workloads. Set 1 core ratio limit to 55. Set 2 core ratio limit to 55. Set 3 core ratio limit to 54. Set 4 core ratio limit to 54. Set 5 core ratio limit to 53. Set 6 core ratio limit to 52. Enter the specific performance core submenu. In this menu, we will specify which P-cores are allowed to boost to our maximum frequency of 5.5 GHz. Set Performance Core 0 specific ratio limit to 54. Set Performance Core 1 specific ratio limit to 54. Set Performance Core 2 specific ratio limit to 55. Set Performance Core 3 specific ratio limit to 55. Set Performance Core 4 specific ratio limit to 54. Set Performance Core 5 specific ratio limit to 54. Leave the specific performance core submenu. Set Efficient Core Ratio to bi-core usage. Now we will set a dynamic E-core overclock. Set Efficient 1 core ratio limit to 40. Set Efficient 2 core ratio limit to 40. Set Efficient 3 core ratio limit to 40. Set Efficient 4 core ratio limit to 39. Enter the specific Efficient Core submenu. We will, pro forma, set the E-core cluster maximum ratio to 40x. Set Efficient Core 0 Group 0 specific ratio limit to 40. Leave the specific Efficient Core submenu. Enter the AVX related controls submenu. Here we will configure the AVX negative ratio offset such that when AVX workloads occur, our system will sufficiently reduce the clock frequency. Set AVX2 ratio offset to per core ratio limit to user specify. Set AVX2 ratio offset to 5. Leave the AVX related controls submenu. Set CPU core cache voltage to adaptive mode. This will make sure the CPU core and ring voltage will scale according to its needs depending on the current CPU frequency. The adaptive voltage will be mapped against our OC ratio, that is the highest set ratio, so in our case 55x. Between the OC ratio and the highest default ratio, for the 12600KF that's 49x, the voltage will be interpolated, so the actual voltage will scale with the actual frequency. Set additional turbo mode CPU core voltage to 1.45, then save and exit the BIOS. To make sure everything is working as intended, we rerun some benchmarks and check the performance increase compared to the default settings. Higher is better and all of our scores are higher. We get up to 26% more performance than at default. When running Prime 95 small FFTs with AVX enabled, the average CPU P-core clock is 4936 MHz and average CPU E-core clock is 3900 MHz with 1.246 volts. The average CPU temperature is 89 degrees Celsius and the average CPU package power is 221.5 watts. When running Prime 95 small FFTs with AVX disabled, the average CPU P-core clock is 5200 MHz and average CPU E-core clock is 3900 MHz with 1.333 volts. The average CPU temperature is 90 degrees Celsius and the average CPU package power is 224.3 watts. The highest core clock reported in the operating system is 5500 MHz. And that's it. Thanks for watching and till the next time.